Hello guys and welcome to my YouTube channel. This lecture is in the continuation of lecture number 1 of kinematics, and in this lecture I will discuss types of motion, what is uniform motion, what is uniformly accelerated and what is non-uniformly accelerated motion. And I will also discuss about the distance and displacement in this lecture. So in the last lecture I have discussed what is motion and also the frame of references, types of frame of references. So now types of motion. So motion can be classified mainly into the three parts. So one part is uniform motion and another one is uniformly accelerated motion, and the next one is non-uniformly motion. This classification is basically based on the velocity and acceleration of any object, how velocity and acceleration are changing with respect to time. Okay, so in uniform motion, velocity of any object remains constant with respect to time, means it is not changing with respect to time. Okay, so this type of motion will be called as a uniform motion. Now the another other one. So if any so and the example of uniform motion, if car is moving in a straight line or in a straightforward road, then in this condition it is moving only with a constant velocity, 20 meter per second for t is equal to 1 second. Similarly for t is equal to 2 second. So means its velocity is constant, and means we can say its velocity remains constant with respect to time. So this type of motion will be called as a uniform motion. Now the other one is a uniformly accelerated motion. So in uniformly accelerated motion, what will happen? Object's acceleration remains constant with respect to time. Means at if we take acceleration of any object at t is equal to 1 second, then it will be equal to the acceleration of any object at t is equal to 2 second, t is equal to 3 second, t is equal to 4 second. Okay, and the very good example of the uniformly accelerated motion is the projectile motion. Projectile motion, when when you are playing the cricket and throwing the ball in a particular direction with an angle theta, then you can see how your ball is moving in the influence of the gravitational force, or in the influence of the constant acceleration is in the y direction. Okay, constant acceleration is small g, which is in the y direction only. Okay, so and the other type of motion is uniform circular motion. So uniform circular motion, you can see uniform circular motion basically in daily life, in daily life examples. Okay, so and the other type of motion is the non-uniformly accelerated motion. In non-uniformly accelerated motion, what will happen? Object's acceleration does not remains constant with respect to time. Means it is changing with respect to time. Okay, so then we can say it is non-uniformly accelerated motion, and the very good example is the moving train. If train is moving, then it may be possible that its acceleration will be different at a different time. So we can say it is non-uniformly accelerated motion. Similarly, if we are moving in a car, then its acceleration does not remain constant with respect to time. Then we can say in some crowded place and in some blank space, so its acceleration does not remain constant with time, it is changing. Okay, so then this type of motion will be called as a non-uniformly accelerated motion. And is if there is another way for the classification of motion, yes, there are another way for classification of motion on the basis of dimension. We can classify the motion in three parts: one dimensional motion, two dimensional motion, and three dimensional motion. So if a car or train is moving only in one direction, then its motion will be called as a one dimensional motion. As here an example has been shown, a truck is moving in straightforward only in the x direction. Now but now two-dimension motion. So the projectile motion and circular motion are the very good example of two-dimension motion. So this is a circular motion of any wall, and if wall is moving in the circumference of any circle. So at t is equal to 0, wall is at the position A, and t is equal to 2 second, wall is here. So wall is changing its position with respect to time and changing its direction. So it's a this means that this wall is having some acceleration, but its acceleration is not changing with respect to time. Then this type of motion is the uniformly accelerated motion and also the two-dimension motion. And it may also be possible a wall is moving in a circular path, but its acceleration is changing with respect to time, means it will be a non-uniformly accelerated motion. Okay, and this also will be an example of the two-dimension motion. And another example of one-dimension motion is a free fall of any object. A free fall of any object in the presence of gravitational force, or in the presence of in the influence of the gravitational acceleration, in the upward direction or even in the downward direction. Now the another classification is three-dimension motion. So three-dimension motion, a plane is we can see here is a plane, and the plane is moving, so its motion will be a three-dimension motion, because it will have some x direction, y direction, and z direction, means x coordinate, y coordinate, and z coordinate. So its motion will be three-dimension motion. Now we will move further. So in this slide we will discuss what is distance and displacement. So distance is the total span covered by any object, and the distance may be positive only. Distance may not be equal to 0 and may not be equal to negative. Okay, so now displacement is the shortest span between initial and final point, and displacement may only be uh, 0, negative, and positive. So it can be positive, negative, or 0, but distance can only be positive. So this is the basically the difference between the distance and displacement. Okay, thank you very much, sir, and subscribe my YouTube channel for further updates.